Hey everyone, how's it going? In this video, we're going to solve an example in which x is used as an exponent, and we're going to show how we can use logs to solve for it. So the question asked is, how do you solve something like 7 times 2 to the x equals 5 to the x minus 2? And there's a bunch of ways you could do it, but the two most common ways you'll see it being done is by either taking the log of everything or the natural log of everything. And those are the two most common ways because that's just that's what a calculator can do. Calculators have buttons for logs and natural logs. So they give you the same answer regardless of which one you pick. So we're going to do it both ways, and you'll see that they give you the same answer, and then we'll check it by plugging it back in. So if we first take the log, we get log 7 times 2x, and the reason I wrote these together is because since these are being multiplied, they kind of count as a single number. And that equals log of 5 to the x minus 2. So we wrote these as the product, but one of the cool things about logs is that if the arguments are being multiplied, then we can split them up into two different logs and add them. And the argument of a log is just the number that you're taking the log of. So for example, here the argument is 7 times 2 to the x. Here the argument is 5. So what we're going to do is we're going to split that up. It's going to get log of 7 plus log 2 to the x equals log of 5x minus 2. So another cool thing we can do with logs is that if our argument is raised to some power, then we can just take that power and bring it out front as a coefficient. So what we're going to get now is log 7 plus x log 2 is equal to x minus 2 log 5. So now all we have to do is use our calculator. So what's log 7? Well, I'm going to do 7, find the log of that. That's going to be, let's call it 0.85. So 0.85 plus, let's find log 2. So we get 2, we're going to find the log of that, that's 0.3. So 0.3x equals, and now log 5. So 5 log gives us 0.7, we'll call it. So 0.7 x minus 2. All right, now we're going to distribute this 0.7 into both of these. So we get 0.85 plus 0.3x equals 0.7x minus 1.4. And now this is just like a typical algebra 1 equation where we gotta bring all the x's on one side, all the constants to the other side, and just solve for x. So I'm gonna bring all of my variables here and my constants here just because that's what's gonna give me positive numbers. So I'm gonna add 1.4 to both sides, and I'm also going to subtract 0.3x. So in the end, what that'll give me is 2.25 equals 0.4x. And to solve for x, we just divide by 0.4, so 2.25 divided by 0.4 gives us 5.625. So we get x equals 5.625. Okay, awesome. Let's redo this problem now using natural log. So if we take this same equation and we take the natural log of things, so we get ln of 7 times 2 to the x equals ln of 5 to the x minus 2. We're going to run through all the same ideas here. Once again, we're multiplying here, so we can split this up into two natural logs. We're going to get ln of 7 plus ln of 2 to the x equals ln of 5 to the x minus 2. We're going to bring our powers down as coefficients. We're going to get ln 7 plus x ln 2 is equal to x minus 2 ln 5. Now we're going to calculate all of our natural logs. So ln 7, we have 7. We take the natural log of that. We get 1.95 So 1.95 plus, let's find the natural log of 2. We get 2 natural log gives us 0.7, so 0.7x equals, and now let's find the natural log of 5. So we get 5 natural log, we get 1.61. So 1.61 x minus 2. Again, we're going to distribute this into both terms. We get 1.95 plus 0.7x equals 1.61x minus, so that times 2, that's going to give us 3.22, let's call it 3.22. Okay, cool. We're going to bring the variables over to the right side again, constants to the left side, just because that's what's going to give us positive numbers to deal with. So I'm going to add 3.22 to both sides, and I'm going to subtract 0.7x. And what that is going to give me, let's see, I have 1.95 plus 3.22. That gives me 5.17, so 5.17 equals, and now 1.61 minus 0.7 gives me 0.91 equals 0.91x. So now to solve this, once again, we just divide both sides by 0.91, so we get x equals, so we do 5.17 divided by 0.91, and we get 5.68. And these aren't exactly the same. They're pretty similar, and the reason they're different is just based on how we rounded. Numbers like 3.22 and 0.7. They aren't exactly those numbers, but because we rounded, that's why we got slightly different answers. But it's always better to stick out with longer decimal places to give you a more exact answer. I rounded pretty tightly for the purposes of this video, but anyway, let's check our answer. So I'm going to use this answer just because it has more decimal places in it. We originally had 7 times 2 to the x equals 5 to the x minus 2. If we plug it in now, we get 7 times 2 to the 5.625 equals 5 to the 5.625 minus 2. Let's see what 2 to the 5.625. So I'm going to get 2 to the 5.625. That's going to give me 49 around. So 49 right here. And now times 7. So times 7 gives us 345 roughly. So 345 equals. And now here we have 5 to the 5.625 minus 2. Well, 5 to the 5.625 minus 2, that's just 3.625. So if we do 5 to the 3.625, we get 342, let's say. And you see, again, they're really close to each other. They're not exact, but they're close. And that just comes down to how we rounded. So because the answer we got right here isn't 100% exact, that explains why these answers are slightly different from each other. But I hope you get the idea. I hope this video helped. And as always, happy studying.